Okay, so we should start by marking the diagram and getting your givens labeled, right? So let's do that. And then we'll kind of look at what we're trying to do in a second here. But we know PQ is congruent to QR. Okay, so let's mark those segments congruent, congruent. And we also know PS is congruent to SR. So these little bottom pieces here, we'll give them 2 little marks. Okay, and let's go ahead and state those as our givens in our first statement and see what we want to do from there. Okay, so statements and reasons. One, I'm just going to put both givens. PQ congruent to QR. I'm just going to put these both in one line here because they're just saying segments are congruent. And that was given to us. Okay. Okay, so now these proofs are going to get a little more in depth. Okay, and we got to think about what we're trying to show and how we could make that happen. Okay. Yes. QS is congruent to itself. Okay, and where are you going with that? That would be yeah, reflexive, but like what made you think to state that next? Okay, so we're kind of doing the triangle thing, right? So we can kind of see that QS is congruent to itself. Okay, so that's definitely what I would do next. Let me just say one thing before I state that though. What we're trying to get at the end, our goal is to show this. Angle P, so this little left bottom piece and this right bottom angle are congruent. So why would it help to have the triangles be congruent? Did you think about that, or were you just kind of okay? Because you're definitely on the right track. Devin, what do you think? Yeah, okay, that's what I'm thinking. If we can somehow show these triangles are congruent, then if these angles happen to be corresponding angles, then we would know they're congruent. Okay, so we're trying to prove like a piece of a triangle is congruent to a piece of another triangle. So let's show the triangles are congruent. Okay, like we said, let's go ahead and say QS is congruent to itself. That's in both triangles. Okay, and the reason anything's always congruent to itself, that's our reflexive. And we need that. Okay, because then that allows us to now use what to say the triangles are congruent? Side, side, side. Okay, they gave us 2 sides, we found the other. So let's just kind of name these appropriately. Could we say like triangle Q SP? So let's just pick the order of one triangle, and then we got to make sure we write the other one in the same kind of order. So QSP, what order does the other one have to be written in? QSR. Okay, the QS needs to line up. Okay, so again, the order we wrote things in, the QS lines up, SP in the first triangle lines up with SR in the second triangle. We knew those segments were congruent. Okay, remember doing all this stuff at the beginning of the chapter? QP and QR, the way they're written, those segments have to line up and be congruent, and they are. Okay, so we wrote this congruent statement correct. The reason here was side, side, side. Remember, anytime you're saying triangles are congruent, it's going to be one of those. Side, 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 side angle, side, all those from the last 2 sections. Okay, yeah, now we do know, since the triangles are congruent, that means all their angles, all the corresponding angles are congruent, all the corresponding sides are congruent. Okay, so that would be our next statement. We could say then angle P is congruent to angle R. Okay, notice how they do line up. They're in the same like location in the way we named them. They are corresponding. They're like in the same spot. Okay, and here's the new step. What's the reason for this? We kind of said it. They're corresponding parts of congruent triangles, aren't they? Yeah, so there's a little abbreviation. Let's write out the long way, then we'll come right back to this. This is a little shortcut that's going to show up in a lot. I'll come right back to the proof. The reason is this. Corresponding parts of congruent triangles, it's kind of a long reason, are congruent. That's it. That's what we use. Yes. Have you guys heard that before? Yep. We actually just use the first letters to abbreviate it because this is going to be a reason we're going to use quite a bit. It's C corresponding CP CTC. That's the abbreviation we're going to use. And you can just write that as your reason. As long as you know what it stands for corresponding parts of congruent triangles are congruent. CPCTC. That's going to be our reason anytime we want to finish a proof like that. Okay? So that's what gets used, okay, as a reason. So that's our final reason, CPCTC. Corresponding parts, congruent triangles, are congruent. And we proved what we wanted to prove. Angle P is congruent to angle R. So one word of advice, anytime you're going to use this corresponding parts of congruent triangles are congruent as a reason, you must have somewhere in the previous statement that two triangles are congruent. Okay, if we didn't have step 3 there, we could not use step 4 yet. Okay, because again, this is talking about congruent triangles and stuff. We have to show which ones are congruent. We did that in step 3. Okay? So any questions on that one? So now you have to still know how to prove the triangles are congruent in the first 3 steps and then take it one step farther to get the final statement. Okay, any question on that? Okay. All right, here is our little abbreviation again. Everyone got that? Okay. All right, how about another example? We'll do it together. Okay, and let's start marking the picture and get some givens out of the way. So, MS parallel to TR. Okay, how do we mark that on the diagram? Yeah, the little triangle arrow things, right? Something like MS parallel to TR. Okay, so let's make that our first statement. MS is parallel to TR. And again, just to save space, I'm going to put both givens on the same line. We also know MS is congruent to TR. So we can give them the little tick mark too. And we'll just do it in one step, save some space on the board. So we had 2 givens. Okay, so now you might want to start thinking about, like, what is our goal here, right? We want to eventually show that A is the midpoint of MT. So yeah, if A was the midpoint, if you look at the picture, MA would have to be the same as AT, right? So if we can somehow show that, then we would know that A is the midpoint. So I'm kind of working backwards here. So how can we get MA being congruent to AT? Yeah, if they're corresponding parts of congruent triangles, that would work. So let's see if we can somehow prove these 2 triangles congruent, and then take it from there. Okay, we got a vertical angle somewhere? Okay. So we can say those 2 are congruent. Okay, and how do we name those? Angle MAS. MAS would be one way. Would be congruent to angle RAT. You want to go with the rat? Or tar? Either one of those. Okay. And reason on that? Oh. Vertical. Okay. Right. If vertical, then congruent. Okay, those 2 are vertical angles. Okay, so we got one side and we got one angle so far. Okay. So we need another side or another angle, but we got to make sure it's the right type of matchup? We don't know that yet. What does the parallel lines do for us? Mm-hmm. Okay. I like it. I like it. Let me extend this a little bit so we can see. So this line is parallel, just so we can kind of see the picture. Those two lines are parallel. Sometimes it helps to extend them. Now the transversal is MT. Okay, we could think of this as a transversal. Okay. Where'd that go? There it is. All right, there's a transversal. Okay. All right. Okay, let's take a look. SMA, this top guy here, and ATR. Are those alternate interiors? Yeah, okay, we got our parallel lines going up the sides, right? Transversal cutting them. They're definitely inside the parallel lines, and they're on opposite sides of the transverse. So yeah, I think that works. Those are alternate interior angles. We know those are congruent. Okay, so we had to have been given that the lines were parallel. We were. Now we can go ahead and say those two angles are congruent. And we can name that, we can name it SMA for that top one. Okay, that has to be congruent to ATR. Okay. Okay, and reason on that, if parallel. Yeah, either the alternate interior angles postulated or something like if parallel, then alternate interiors are congruent, something like that, right? Okay, or you could just say the alternate interior angle postulate theorem. Okay, so see how we used the given. We used the fact that they were parallel to like get you something else. That's usually how this works. It's like putting a puzzle together. If they give you something, you're usually going to do something with it. Okay, so they gave us the lines are parallel. That brings into play all these alternate interiors, correspondings, all that stuff. Okay, do we have congruent triangles? Okay, we have two angles and a side. Okay, we have angle, angle, side, because the side is not the included side. So we have two congruent triangles. Let's name them carefully. Triangle. Okay, if we go MAS, it's congruent to, now we gotta name this one, we gotta match it up. Look at the angles. M is the same as what angle in the other one? T. Okay. Angle A in the left triangle is the same as angle A in the right. And then angle R and angle S would kind of correspond. So it has to be tar. Mas tar, more tar. Okay, so we know those are congruent because of angle, angle, side. Angle, angle, side. Okay, so that's like where we would have stopped last section. Just prove the triangles are congruent. Now we're just doing one more step. Or it might be two in this case, actually. It is, yeah. It's putting a lot together. All right, so again, we got the triangles are congruent. So if they're congruent, what does that mean? All the corresponding sides are congruent. So which side do we need to state again? Think what our goal is. A is the midpoint of MT. MA is congruent to AT. Okay, and again, make sure they match up. Look at the order we wrote the congruent statement in. MA is here. AT or TA is there. That's the same segment. Those are corresponding. They're the first two letters of each. The order is very important. Okay, so we now know that MA is congruent to AT. Reason? That's the new one. Yep. That's the one where right, we had just shown triangles are congruent, right, in the previous step. And then we said now the corresponding parts of those congruent triangles are congruent. Okay?
If you mess up the order with that on the test, would you get that? If you like said CPCTC, would you
I
get
mean,
that?
probably not, but don't rush through it. Just go through it slow. It's corresponding parts of congruent triangles. Just be careful with it. Okay? Question. Yeah, that's what we just did, right? MA to AT. All right, yes. Uh-huh. Yeah. Always after you've shown triangles are congruent. All right, now what's our last step? Look at our goal. Yeah, now we know A is the midpoint. Okay. A is the A is the midpoint of MT. Okay. All right, stay with me, guys. There are a lot of steps. So that was what our final goal was. We wanted to show that, right? And the reason is that's right. That's the definition of midpoint. From what we had just shown before, that means that A is the midpoint because that's the definition of a midpoint. Okay. So now we're done. Okay. So yeah, a lot going on there, definitely. Okay. And you got to keep yourself organized. Got to go slow. Okay. Oh, there's some ridiculous ones like in after you get to calculus and prove a bunch of that kind of stuff. It's ridiculous. Um, after this class, you probably won't do proofs again until like college. Yeah, if you go advanced math. All right, what you got? Before that, let me.
MT is congruent to SR. Wait, isn't angle M?
Okay, good. So if we take these one at a time, if A is the midpoint of MT, that means it cuts that in. So those two are equal. Okay. So that would be a good next thing to do. MA congruent to AT. Okay. Okay, what else is kind of a direct consequence of our given? What's the other part? Okay, yeah, if we're the midpoint of SR, then these two are also congruent. But we don't know that like all four are congruent to each other, so I'm going to use two marks in the SA part and the AR part because they could be different than the MA and the AT part. Okay, but we do know they're congruent. SA, okay. Reason there for both of those? Okay. We were given a midpoint, that's what it means to be a midpoint. Okay. All right, so that's kind of the part that was kind of handed to you. Where from here? Okay. Yes. Okay, angle MAS. So this guy in here. And RAT. Okay, so kind of similar to what we used in the last one, vertical angles there. That might help. Okay. Yep, the Moss rat. All right. Those are vertical angles. Okay. All right, what do we got, Gayla? By Okay, perfect. Now we have enough. Okay, we got two sides from the givens. We just got an angle. We got an included angle in both. We got side angle side now. So triangle MAS. Okay, would have to be congruent to triangle. Which way do we write it? TAR. Yeah, it's got to be TAR. Yeah, because I'm looking again, and I could tell that because I'm looking at the way it's written. So MA. Okay, if you look at side MA up here, that's congruent to side TA. So it has to be like in that order of things. Okay. Let me just get my reason, then we'll take it from there. That was what, side angle side? Okay. All right, now what?
Alright, I said that angle M,
Okay.
that angle M is congruent to angle T,
Okay.
the CPCTC.
Okay, I like it. Angle M is congruent to angle T. So M and T, again, we can see those are the first letters in the way we named them. So they're corresponding. Angle M is congruent to angle T. We have corresponding parts of congruent triangles congruent. That's the new little tongue twister there. All right. All right, now can we say the lines are parallel?
Yes, MS is parallel to TR
Okay, because what?
because of the alternate interior angle C.
Perfect. Okay, here's what we have now. We're trying to show that this and this are parallel. We're trying to show that, right? Okay, here's a transversal cutting it just like we did before. Now we've shown that angle M and T are congruent. Those are alternate interiors. So this is like the converse where we say if we know those are congruent, then the lines are parallel. Alternate interior angle converse. Proves the lines are parallel. Okay. MS is parallel to TR. Okay. If alternate interior angles are congruent, this is just kind of writing it out the long way, then parallel. Or you could simply write the alternate interior angle converse. Okay, in the last proof we used the regular if parallel then something. Now we're using if congruent then parallel. We're using the converse, the other order. Okay?